dear students. So today we are going to see about the chain rule, how it serves the purpose in backpropagation algorithm. So quickly moving on to today's topic, chain rule is a fundamental concept that you actually see in calculus, and it is very helpful in calculating the derivative of the composite function. Now why do we require this derivative? Because we have been keen on calculating the gradient of our loss functions with respect to any parameters, right? So we used to find out till this part, right? Like we have been learning so far. So we are very keen over derivative of any function, especially here our loss function. So in this chain rule, it will help you to calculate the rate of change of a function. Rate of change of a function is again the derivative, the gradient of a function. It can be it can be expressed at or like more than two functions which are nested inside each other. What is it? You will come to know just in a while when I will show you the equation. So the chain rule is very important in calculus when it is dealing with functions where one quantity is actually dependent on another quantity. So as we all know, loss function is dependent on the parameters of the model like weights and biases. So how they are dependent? So if there is some any dependency, then still you will be able to calculate the gradient using chain rule. So it is a very powerful tool that will enable us to find out the derivative of a complex function, wherein it breaks down the complex function into simpler functions, and then it is going to consider how the changes in the inner function affect the outer function. Okay, so that's what we are going to see in this particular chain rule. So you can see here, if I put it down mathematically, the chain rule is as simple as that. So you can see it is nesting of functions. So you have got here a function y is actually dependent on two more functions. So you are having an input on which you are calculating a function. Again, it is nested as another function. So f of g of x. So y is your final output or a dependent variable that we call. And if I consider this as u, then f of u is your outer function and g of x is your inner function. Okay, so suppose you want to calculate the derivative of dy, that is the dependent variable and the independent variable x. Then if it constitutes of two functions, then very easily you should write it as df by du into du by dx. So using this particular equation, very simple chain rule, you can easily calculate the derivative or the gradients of many complex functions. So the chain rule says that to find out the derivative of this composite function y is equal to f of g of x, you must multiply the derivative of the function f of u with respect to its variable by the derivative of the inner function of g of x with respect to x. That's how it is written. So this is a very simple chain rule, and it really slows down the complexity of your mathematical function. So now quickly moving down and calculating another function, that is you have got if I want to really talk on neural networks, how it is benefited. So in the context of machine learning and neural networks, the chain rule plays a crucial role in gradient propagation during the training process. So it's very, very important. So you all know that back propagation, what do we do? I mean, in neural networks, what do? We calculate, we give an input x to our model and we calculate the output y. But we know that there's a difference between this predicted output and the actual output. So we calculate the loss function, and we always want to minimize this loss function. So how do we do? So we know that this particular model is being influenced by other parameters like weights and biases. So we have to fine tune our weights and bias so that it gives you the minimum loss at the end. So for that, once you begin with initializing your weights and biases, you have to always look into calculating the loss and now update it. So how do you update it? You have to go reverse. You have to calculate back from the output towards updation of your input parameters. So that's why it is called back propagation, and that's how gradient propagation is required here. So gradient propagation is nothing but the process of computing derivatives or the gradient of the composite functions like a neural network with respect to its parameters like the weights and biases. So the chain rule is to calculate these gradients very efficiently, allowing the neural network or your model to update its parameter during the training through the process called optimization, and the algorithm one such is gradient descent algorithm. So we will see that more in detail. Now for that you understand this is what is chain rule and how it is important in calculating the back propagation. Now let's see what exactly is happening in a neural network. So you can see here in the neural network forward pass, the input data is processed through multiple layers, right? You know what is happening inside a forward pass. So what are you having inside a forward pass? You're having a weight, you have this input, and then you have this bias. Okay, so these three will go into a linear relationship, and then you apply an activation function, and then what you get is an output. So that's what I am going to give here. For every layer, I have an intermediate output H1. You have this input data X. My layer 1 has got output H1. So it is going to work on the first weight and bias and then apply a mathematical activation function to it and gives me H1. Similarly, second layer, so on up till my output layer. So my final output layer output is Y. And my final activation function is F0 that I am writing. I don't know how many layers are there, so I am writing K into H and then output weight and then the output bias, whatever you are using. So this is how you will calculate the outputs of every layer, and this procedure is called as a forward pass. Alright, so please remember these terminologies as and then you needed. Okay, now moving on, once you have done with the forward pass, as I told you, you are supposed to use a loss function. It can be a cross entropy loss if you are going for classification application, or if you are going for anything like regression, go for a mean squared error loss function, as simple as that. Now moving on, once you calculate the loss, you have to go for gradient calculation, which is through backpropagation algorithm. Now this is an optimization technique whose goal is to minimize the loss function. Now in order to do this, you need to calculate the gradients of the loss with respect to the parameters of this model. So what are the parameters of the model? The weights and biases. So for every layer you have got weight and bias. For every layer you will have to calculate gradient of this loss function with respect to weights and biases. Now this is the point where chain rule comes into picture, and it really eases out our mathematical calculation. So but because it doesn't start from input, it actually starts from output. That's why it's called as a backward propagation. Okay, so starting from the output layer and moving backward throughout the network, you will calculate the gradients layer by layer using the chain rule. So this is how you can see that chain rule helps you in back propagation. So quickly moving on and seeing how does it do. So computing the gradient of loss with respect to the output layers input, and then propagate this gradient backward through each layer by multiplying it with the gradient of layers input with respect to its parameter. Very simple, I'll tell you. So as I said, we will move with the backward layer. So I am calculating gradient of loss function with respect to first backward parameter W0. So it is nothing but d loss by dy into dou loss by dou y into dou y by dou into what is the penultimate thing again? The W0 into HK plus B0. Correct? Yeah. So now similarly you will calculate for bias, weight and bias. Once it is done, this first layer is over. First layer from the output side. So first, then we'll move for the penultimate layer. So you will have now, suppose it will have dou L by, suppose you are coming to second weight. So it will be dou loss by dou y into, you will have dou y by dou of W2 H1 plus B2 into dou H1 by dou of W2 H1 plus B2 into, you will have dou of W2 H1 plus B2 by dou W2. So this you will have to remember, this is the place we are actually using our chain rule to make our backpropagation much more simpler. So if you understand the formula for chain rule, you will understand how you have been writing this particular derivative of loss function with respect to the parameter. More on this we will be seeing once I teach you backpropagation. Every clarity will come to you. So I think I will stop over this for chain rule, and in the next session we will see how this will be applied in backpropagation, and hence you will get all the clarity.